In this video, we're going to work through trigonometry in a right-angled triangle. You might know it as SOHCAHTOA. We're going to start with the easiest exam question and work right through to the hardest. Pause the video, have a go, and then we'll go through it together, step by step. ABC is a right-angled triangle. Work out the size of angle X. Give your answer to 3 significant figures. Okay, so whenever you get a question like this with a mixture of sides and angles, lengths and angles, you need to think of these 3 little triangles. I've popped them up at the top of the page for us, so we've always got them. Now remember, the hypotenuse is always the longest side and it's always opposite to the right angle. So this is the hypotenuse. We're looking for angle X, and the one opposite angle X is the opposite. And the one next to angle X is adjacent. So we have got O and A. So the triangle with O and A is this one with the T in it, tan. So tan X is equal to opposite over adjacent. So 11 over 13. Now we just want the value of X, so we do inverse tan, so X equals tan to the -1, looks like this, and then in brackets we've got 11 over 13. Okay, so put that on your calculator. Remember you have to press shift or second function and then the tan button to get the tan to the -1. 11 over 13, close your bracket and press equals. Your calculator needs to be in degrees, so somewhere at the top of your screen it should say D or DEG. You don't want to see R or RAD. So putting this on the calculator, we get 40.236 ... and we're going to round to 3 significant figures. So that's 40.2. We don't need to round up because the 3 is less than 5. ABC is a right-angled triangle. Work out the size of angle X. Give your answer to 3 significant figures. So it's the same process we did before. Start by labelling the sides of your triangle. This one's the hypotenuse, it's opposite the right angle. This one's opposite because it's across from the X. And BC is our adjacent. So this time we've got opposite and hypotenuse. So that's going to be sine. Sine X is equal to the opposite over the hypotenuse. Sine X is equal to 7 over 9. We want X by itself, so we want inverse sine. X equals sine to the -1 of 7 over 9. Popping that on our calculator, we get 51.057 ... and we want to give our answer to 3 significant figures, 3 numbers. 51 point, and this time we do round up, so 51.1. ABC is a right-angled triangle. Work out the length AC. Give your answer to 1 decimal place. So this time we want to find a length, but our steps are the same. So I'm going to just keep the length called AC. So first of all, we want to know what 12 is. Well, that's the hypotenuse. It's opposite the right angle. And then the length we're looking for is the adjacent. It's next to the angle we want to find. So we've got A and H. So this time we're using cos. Now we want to find A, so we need to do cos times hypotenuse. So AC is equal to cos 37 times 12, or 12 cos 37. Then we're going to put that on our calculator. Remember, it's not inverse cos this time because we already know the angle. So 12 times cos 37 equals 9.58 ... and round it to 1 decimal place. So 9.6. ABC is a right-angled triangle. Work out the length AC. Give your answer to 1 decimal place. Okay, so the length AC is the hypotenuse, it's opposite the right angle. The length AB, or 7.5, is the opposite. It's opposite the angle. So we want one with opposite and hypotenuse in it. So that's going to be this one, the sine one. Now we're trying to find the hypotenuse. So that's O over S. So we've got opposite is 7.5 divided by sine 50 is equal to A to C. And we can pop that straight onto our calculator. 7.5 divided by sine 50 and press equals, and that's 9.79 ... And then we round that to one decimal place. We've got 9.8. Make sure you always show your workings with these questions. Then if you get anything wrong with the calculator, you're still going to get some of the marks. A ladder rests against a vertical wall. Calculate the angle X the ladder makes with the floor. Give your answer to one decimal place. Okay, so it talks about a ladder, but you can see it's just a right-angled triangle. You've got two lengths. You've got the opposite, because it's opposite the angle, and the adjacent, because it's next to the angle. And opposite and adjacent is the triangle with tan in it, TOA. And we'd like to find tan. So tan X is equal to opposite 5.7 divided by adjacent 1.3. So this time you are trying to find the angle, so you need inverse tan. X equals tan to the minus 1 of 5.7 divided by 1.3. Put that onto your calculator carefully and you should get 77.152. And then we're going to round it to one decimal place. So that's 77.2. Calculate the size of angle BAD. Give your answer to three significant figures. So we're going to cut this shape into two parts so that we end up with a right-angled triangle. So we cut it across here. You can see that this makes a right-angled triangle. And this base length here must be 8 because it's the same as the bottom. And then if you look up the side, you know that from B to A is 6 meters and from C to D is 10. So the bit that's left must be 4. So you now have a right-angled triangle where you've got 8 here, 4 here, and you're looking to find this angle. Let's call it X. So we've got the opposite and the adjacent. Tan X equals 4 over 8. Then X must be equal to tan to the minus 1 of 4 over 8, which is equal to 26.565. I'm just going to leave that on my calculator for a minute because I've got to find the whole of angle BAD. So I need to add on this part in the rectangle. And I know that the angles in a rectangle are 90 degrees. So I need to add on 90 degrees, which gives me 116.56 ... And I need to give it to three significant figures, so 3 numbers. So remember, you still need to round correctly. So the 0.5 makes it round up. So that's 117 degrees. ABC is an isosceles triangle. AC is equal to BC. Calculate the size of angle ABC. Give your answer to one decimal place. First of all, let's mark on angle ABC. Start with A, look for B, find C. So it's this angle here. Now, how do I make a right-angled triangle from this isosceles triangle? Well, if you cut it down the middle, you can put a right angle in. And remember, when you cut it down the middle, you're going to need to halve the base. So this length here is going to be 8. So the triangle I'm going to work with has got 8 and 22. The right angle's here, and we're looking for this angle here. Let's call it X. Okay, so we know the hypotenuse, the longest one, and we know the adjacent, and we're looking for an angle. So which one has hypotenuse and adjacent? So that's cos. Cos x is equal to adjacent, which is 8, over hypotenuse, which is 22. So x must be equal to cos to the minus 1 of 8 over 22. Using your calculator, you're going to get 68.6763. And we're going to round our answer to one decimal place, 68.7. ABC and BCD are right-angled triangles. Work out the size of angle BCD. Give your answer to 3 significant figures. Which is angle BCD? This one here, yes, follow it round. Let's call it X. Now we work well with right-angled triangles. We know one of the lengths in it is 30, and we could do with to find out what this length here, D to C, is. We know all the way along the bottom is 87, but we need to know what A to D is first, so we can take that away and find out what's left. So starting from triangle ABD, we're going to try and find the length AD. So AD is the adjacent and 30 is opposite. So we want one with opposite and adjacent, so that's tan. And we're trying to find the adjacent, so we want opposite over tan. So 30 over tan 32 is equal to A to D. Put that on our calculator, 30 divided by tan 32, and we get 48.010 ... Let's leave that on our calculator for a minute. Now we want to know the length D to C. So if we do 87 minus our length for A to D, the answer we've got, we can find what D to C is. So that's 38.99. And now we're going to use this new triangle over here, BDC, to find the size of angle X. So we know the opposite and we know the adjacent. So tan X is equal to 30 over 38.99. And then we want X is equal to tan to the minus 1 of 30 over 38.99. And if we put that on our calculator, we get 37.575. And we need to round that to 3 significant figures, 37.6. This is quite a tricky topic, and it's definitely going to come up in your exams. So that you can keep practicing, I've linked a free worksheet with worked solutions. Remember, if you subscribe to my channel, you'll never miss any of my videos or worksheets again.